Welcome back to the ChemDoctor, and this is the second video in the playlist on naming ionic compounds, polyanions, and so on. And what I did in the first video is I laid out the elemental ions, and what we're going to do in this video is we're going to talk specifically about naming metal cations, and I'm going to introduce the issue of the polyanions. So first, the metal cations, and what I want to start with is an atom of sodium. So if I write this symbol in this form and I use this word, the symbol and this word have a specific meaning. We're talking about the neutral form of this element. What do I mean by that? All right, so if you look on your periodic table, you'll see that sodium has got 11 protons. In the neutral atom, that means it also has 11 electrons. So there is no net charge on this element. And if I was to write a sentence where I was going to use neutral sodium, I would use simply the word sodium. It might be followed by sodium metal in a lot of instances. Authors will add that additional adjective to emphasize the fact that you're dealing with the metallic form of this element. All right. Now, how is this different from the ionized form? So the ionized form of sodium is this, Na+. And what this means literally is that this form of sodium has actually undergone a chemical reaction, most likely with a nonmetal of some kind, or some kind of molecule, where it has literally given up one of its electrons. So if I was to do a simple sum so I could see what that meant, I could write down, for example, the total charge from the total number of protons that sodium has, which is 11. Since this has given up one electron, then we need to add on the number of electrons that it still has, which should be 10. When you take the sum of this, you get +1. That's where the charge comes from. Now, you cannot call this molecule, you cannot call this species sodium, because if you call it sodium, what you're really saying, language-wise, is that this thing is in its neutral form. It's metallic sodium. It's got 11 electrons and 11 protons. So we need to call this something else. So technically speaking, what we're going to say is that this is sodium ion. It's important to use this adjective because then it's absolutely clear which species you're talking about. Okay, so for all metal cations, what you're going to do is you're going to use their elemental name followed by the word ion, and it's very clear then that you're talking about the positively charged species. Now, in terms of the elemental ions, in either group 1A or group 2A, you automatically, when we use this term ion, we know what the magnitude of the charge is because we have it memorized and we know it for certain. Now, when we move into the transition metals, we've got some problems because, and I'm going to focus on iron first. All right, now, again, if I'm going to talk about the neutral element, then I simply call this iron. There's no ambiguity with this. If I use the word if I use the word iron, then I mean this element where it has the same number of electrons as it does protons and carries no formal charge. Now, let's extend this idea. Let's say I call it iron ion. Now, for a transition metal, we're most likely in trouble. And the reason that we are is because even though this tells the reader, or in the case of somebody speaking it, saying iron ion, it's clear that iron has a charge. but which one? Because iron readily forms Fe plus 2 and Fe plus 3. And this is the issue with the transition metals. They have multiple what we call oxidation states. They have multiple forms of ions that they can make when they react with nonmetals or with another type of molecule. So what are we going to call these? You simply can't say iron ion, because in this case, which one do we mean? And there are other examples of this, like copper readily forms the +1 cation and also the +2 cation. So for the transition metals, in addition to the word ion, we are going to utilize a Roman numeral to indicate the magnitude of the charge. So for this one, what we would say is that we would call this iron 2. And we could leave it at that if we want, or if you want, you can say iron 2 ion, which is somewhat ambiguous actually. Iron 2 is probably the preferred method for this. The Roman numeral tells you that the charge on this cation is +2. So I'm going to put this in words because oftentimes new students confuse the Roman numeral to mean the number of iron atoms, which is incorrect. So the Roman numeral gives the charge on the cation. Gives the charge on the cation, the metal cation. So for this guy here, this would be iron 3. And for the copper 1, this would be copper and then Roman numeral 1. And when we speak it, we would say copper 1. This guy here would be copper 2. Now, these ions also, many of them have common names. And for brevity, I'm not going to get into that on this video. We'll do that on a different one. The main thing is that make sure that you understand how the Roman numerals work. Maybe we should do one more example. So if we look at chromium, it has 2 forms. Well, actually it has more than that. But for comparison, I'm just going to use these 2. There's also chromium 6 and so on, but I'm not going to worry about that right now. So for this guy here, we would call this chromium 2. And now there's no ambiguity about which ionized form we're dealing with. And this one, chromium 3. So again, the Roman numeral is indicating the charge. Now, let's spend a few minutes talking about the polyanions. So, what is a polyanion exactly? Okay, a polyanion, number 1, is what we call a molecular ion. Alright? Molecular is an important term because it comes from the dominant word, which is called molecule. And molecule comes from what we call molecular compounds. Or another way of looking at this, and I'll change the color, would be from a covalent compound. All right, now, what differentiates a covalent compound from an ionic one? All right, and the ionic compounds, let me just put this over here. An ionic compound all right, sorry about that. Let me just fix that up really quick. An ionic compound contains usually a metal combined with a nonmetal. All right, metal with a nonmetal. Your covalent compounds, molecular compounds, usually are going to be where you've got nonmetals that are combined with nonmetals. So your molecular ions literally are covalent compounds that have a charge on them. That's what a molecular ion is. It's a covalent compound that's comprised predominantly of nonmetals that carries a charge. All right, so if we look at some examples of these, for example, here's the carbonate anion. All right, its name is carbonate. It carries a charge of -2. Typically, you find these in ionic compounds where a metal is combined with this. And you can see right away when we start thinking about potentially naming these things, you will have to know the name of this. All right, and then there is another example of common polyanion. This one's called phosphate. Now, this is a good example because this one has a related compound that it has this formula, PO3 -3, which is called phosphite. So, the polyanions, generally speaking, are going to be found in Chapter 3 of your general chemistry textbook. If it's not Chapter 3, it's going to either be Chapter 2 or it'll be Chapter 4. There's usually somewhere around 23 of these. You're going to need to have them memorized, both for name and for formula, which will become more apparent in the next video as we start to explore how we actually do the naming. All right? And with that, I'm going to go ahead and close this video.